Good morning, ladies and gentlemen. This is Mr. Hunter, and this is a review video for your review quiz that's coming up on electrostatics. Electrostatics. The first thing that we have to do is talk about charge. Now, and when we talk about charges, we have two types of charges. We have a positive and a negative, which consists of the proton and the electron. So since these things are so small, we can't see them. So we use a model such as a simple circle with a positive and a simple circle with a negative. And we have to remember that these all have the same elementary charge of E, which is 1.6 times 10 to the negative 19 coulombs. And if it's a proton, it's positive. And if it's an electron, the value is negative. Now, hopefully you remember that opposites attract and like charges repel, which means negatives don't like negatives and positives don't like positives because around each of these charges are electric fields. And these electric fields do various things. So with the positive charges, it comes out of positive charges. And with negative charges, the electric field lines go into the charge. So with these two positive charges next to each other, the electric field lines leave the charge, excuse me. So the electric field lines go out of positive, but as they come next to another positive, they push away from each other. Why? Because both those lines are positive. And the same thing with the negative, as they're going into the negative charge, they push away from each other because both those charges are negative and they don't like each other. So remember, with electric field lines, they come out of protons and they go into electrons. I'm trying to quickly draw this. So that's why positive charges and negative charges, when they're next to each other, attract, and that's why negative charges next to negative charges and positive charges next to positive charges repel, because they don't like each other, in particular because the electric field lines are either pushing away or they are attracting to each other. Now, that also means that when you have this repulsion, when the electric field lines are pushing away, the electric field between those spots are 0 newtons per coulomb. Now remember, the electric field is a measure of how strong the field is as a result of the charge that's there. So it's E equals F electrostatic force divided by charge. And that's right on your reference table. So if they're like, what's the electric field at this point? Or you have this charge and here's your electric field, what's the force that the charge feels? Then you can use that equation to figure it out, which also brings us to the electrostatic force equation, which, just like gravitational force, it's the electrostatic force between two charges separated by a certain distance. And so you got to remember that 1 over r squared relationship. So if I have two charges next to each other, and they have, like, let's say this is 2 coulombs and this is 1 coulomb, which is super huge, you can actually figure out the electrostatic force between those charges using the equation. K is just the electrostatic constant you get off your reference table. Q1 and Q2 are the charges, the values of the actual charge, which is measured in coulombs. Remember, you need to remember all your units, like force is measured in newtons, distance is measured in meters, charge is measured in coulombs. You guys are really struggling with remembering the units, even though the problems tell you most of the time what they are. So that's your job. Your job is to know those. So you can figure out the electrostatic force between two charges. And just very briefly, remember there's this inverse squared relationship between force and distance. And remember what I taught you in the other video, when you're trying to figure out a graph or the relationship between two values, you essentially plug them into a T-chart. Everything else gets set to 1 that doesn't change. So K, Q1, Q2 aren't changing, only the distance between the two variables, and then you just plug in values just like you're making a graph. So for example, if this is R and this is FE, well, R is going to go up by 1, 2, 3, 4, 5, and then mathematically I just put in what it does when it goes up. So like 1, well, 1 squared is 1. 2, well, 2 squared is 4. 3, 3 squared is 9. 4, 4 squared is 16. 5 squared is 25. 6 squared is 36. And so if I were to graph this, my electrostatic force, when it's at 1, is at 1. What am I doing wrong here? So the graph should look like this. The force should drop exponentially, and that's not what my graph shows. I think it's because I have my axis backwards. Because remember, it drops by a factor of 4, or if it's squared, or if it drops by a factor of 9, if it's quadratic. So I think I just messed up my axis. But that is essentially the relationship between the electrostatic force and the radius, because as the distance increases, your force drops by a factor of r squared. So let's see. So that's electrostatic fields. That's forces. What am I missing? Let's see. More review. Okay. So with the movement of charge, you also have to remember that charge is quantized. And what that means is it can only exist in multiples of this value. So remember, you can't have half an electron, you can't have half a proton. You have to have multiples of this value of 1.6 times 10 to the negative 19 coulombs. So I remember there's a question that I gave you guys on your assessment as well as your quiz, which it was like you have plus 1.6 C and then minus 2.3 C and then like negative 4.8 times 10 to the negative 19 coulombs. And they said, which of these charges are actually possible? The answer is that, because that is 3 electrons. Because since C is your charge of Coulomb, these should be whole numbers. So those can exist because that should be 2.0 and that should be 1.0 or 2.0. So you need to remember that charge exists in discrete values, or basically can only exist in multiples of this value. And if it's not a multiple of that value, it cannot exist. Let's see. So charge is quantized. Charge is also conserved. So, for example, if I have 2 spheres, right? One is negative 3C, and one is plus 5C, right? And they touch together. When they touch together, the charges are going to essentially cancel out. So plus 5 minus 3 is plus 2C between those 2 charges. And then when you separate them, because the charges push against each other equally, they'll both distribute that charge between the spheres. So after they touch, each of those spheres are going to have 1 coulomb, or positive 1 coulomb of charge, which also leads me to remember one elementary, or actually, sorry, there is in 1 coulomb, there is reference table. I believe it's 6.25 times 10 to the 18 elementary charges. 6.25 times 10 to the 18 elementary charges, which is a lot. And sometimes you're told how many elementary charges you have. But remember, 1 elementary charge is 1.6 times 10 to the negative 19 coulombs. So, for example, if I told you you have $50, right? Or actually, I'm sorry. I tell you you have 50 $10 bills. And then I say, you know what, what's your total? Well, what are you going to do? You're going to multiply those two values to get your total, and you're going to do the same thing here. So, for example, if I said you have $50, or not $50, you have $50 bills, you have 50 $10 bills, you would multiply those two values to get $500. Sorry, it's early in the morning. I am stuttering horribly. Um, However, it's the same thing with the elementary charges. If I say you have 16 elementary charges, and you know that one elementary charge is 1.6 times 10 to the 19 coulombs, you multiply to get your total charge, and vice versa. If you're told, here's the total charge, how many elementary charges, I divide out, just like you would with money. Like if there was 10 of you, and I had $10, and I'd say, how much would each of you get? You'd be like, oh, Mr. Order, we get $1. It's the same thing with the elementary charge. Same basic math, nothing new. Those are the basics of what is going to be covered on your review quiz with electrostatics and the electrostatics and the movement of charge. Remember the electroscope, I could throw questions like that on you, which just simply deals with the movement of charge. I can also ask you questions about what would happen if a car is struck with lightning. But that is overall your electrostatics in a nutshell.